If you're a phone technician or you do phone repairs, a multimeter is a must. Even if it seems a little technical, it's something you should learn how to use. And in today's video, I'm going to show you some basics on how to use the multimeter, as well as just a review of this product. Kaiweets was kind enough to send me this for review, as well as their 23-in-1 DC power supply cables. So we're going to go over all these tools, how to use them, and hopefully you find this helpful. You learn something new about troubleshooting and diagnostics. So hi, I'm Jesse from VCC Board Repairs. Thanks a lot for joining us here on the channel. If you like my tutorial videos where I teach you how to do phone repair, troubleshoot, diagnose, smash the like button, subscribe to the channel to see more like this, and share this video with all your friends. Down below, I will link to where to buy these, as well as some other micro soldering tools, some t-shirts like this one, and my VIP community that you can join to support the channel. So let's go ahead and get started and check out these cool new tools. So the first thing you're probably thinking about is, what is the price? So the Kaiweets KM601 multimeter is $45.99 as of this recording, and there's actually a coupon for $5 off. Now the cable kit is $42.99, and there's a 10% off coupon for that as well. So total, you're looking at about $80. Now if you compare this multimeter to the price of my Fluke 115, which I bought a few years ago, it's $218. So it's a huge price difference. So especially if you're first starting out or you don't do board level repairs, you still need a multimeter. It's so useful for even basic stuff. So you probably don't want to spend $200 plus for a multimeter. So this is where a Kaiweets multimeter comes in handy. Now there are other brands and there's probably cheaper ones out there as well, but I do want to show you guys some of the functions and features of this one, and maybe you'll want to get it. You know, Kaiweets did send me this for review, and I have done some testing on it, and it does work pretty well. So let's go over the actual products themselves. Let's unbox it and see what's inside and test them out. So first thing is unbox the multimeter. It comes in this box with the user manual, which does have detailed instructions for each function. It does come in a fancy little carrying case. It comes like this. So here's the main units, which we'll come back to in a second. It does come with the extra set of batteries. So there's already 3 inside the device, plus extra 3. So, you know, a lot of multimeters do come use 9-volt batteries. So this is pretty nice. Most people have spare AAA. Whereas 9 volts are a little more rare and probably more expensive. So it does come with multimeter probes, as you would expect. These probes do come with these little covers as well, so that's pretty nice. This kind of helps prevent bridging or shorting the probes together. If you're like doing something really close and it slips, you won't short them. But these probes are a little too thick for micro soldering, like board level repairs. They're really big compared to a motherboard at the microscopic level when we're doing that kind of stuff. And it does come with a temperature probe as well. So we'll test this out and see, if it's any good. Now here's the actual main units. I have been using it. I used it a few times already, and it does work pretty well. It does have the size and shape of a smartphone. Now here's my S22 Ultra. As you can see, is very similar in size. So it does have that cell phone design as well. It looks like an OtterBox case. So to get into the battery compartment, you do have to peel off this case, which is very rugged. Take off the screw, and then the batteries are in here. But outside of that, you put this back in. And let's turn it on with this power button by holding it. There you go. So one of the nice things about this is it has a color display. It is very bright, although probably only good for indoor use. If you're in direct sunlight, positive, this will be very hard to see. But for phone repair, this is what we do indoors in the office. So So yeah, on the side there's a flashlight button, which is pretty handy. There's a non-contact voltage sensor, and then the auto power off function. So if you want it to go to sleep or turn off after no use, it'll help save the battery. Although sometimes you do want to turn it off if you're doing something and you hate having to keep turning it back on. So there's that. So when you first turn it on, you actually notice it's in auto mode. Basically, it's trying to guess what you're trying to do, either measure voltage, ohms for resistance, or continuity. But if you click the red button here, you'll basically go into a manual mode. So you can switch between all different modes. If you press and hold it again, you'll actually go back to auto mode, and then you can click and start over. So if you go past the function that you wanted to use, just do that, start over. Now, let's go over some of the functions here and kind of explain how they work and how you use it in a real world scenario like phone repair. The first thing you want to do is plug in your multimeter probes. So there are some caps here you remove, and then you plug in the black one to COM, and then the red one for pretty much all the functions. You want to use this one here on the right. Plug it in, and now your multimeter is ready to use. Now let's go under the microscope and go through some examples. All right, so right now it's in auto mode, and we have a battery here. Now pretty much all batteries have a positive and negative terminal, and it doesn't really matter which probe goes where. Essentially, you'll always see there's some large pins and smaller pins. The large ones are the ones that are passing current and voltage. The small pins are just data lines. So that's why pretty much look at any battery, you'll see essentially this. Now there are some batteries that only have positive and negative as well. So here, let's check it out. So you actually can see the traces here as well. So that should give you a clue, like this is either positive or negative, and this one's either positive or negative. So if we probe the pins here, you'll actually see I'm measuring negative 3.56 volts in DC. If I flip these over, then I'll read positive, that same reading. Now you could also probe the pins as well. Oops, am I making good contact? There it goes. Now, resistance mode. Here's an iPad board. Here's a resistor over here. So we're still in auto mode, but you'll see it'll figure out that I'm trying to measure a resistor and actually give me an ohms value. All right, so I'm going to just probe across it. Now this one for sure doesn't matter which goes which. And you'll see I have a number of 989, 990 point something. And below that, you'll see a K and an ohm symbol. So that means 990K ohms. So 990,000 ohms. And the next is continuity mode. Basically, that's if you want to check for shorts or check for ground. Basically, any continuity to ground. So one way to test that is just touch something metal to something else that's metal. So like the top of NAND and this metal shield. And you'll hear it actually beeps, and the number is 000. So this is one way to check for shorts. So you just probe, any probe on ground, and then probe something. So that's not shorted, not shorted. So that's shorted, not this side. Well, not shorted, it just continuity to ground. Oh. So basically, you can probe stuff for shorts. So that has continuity to ground, but this side doesn't. This side ground, not ground, not ground, ground. So essentially, you use continuity mode to see if something's grounded. That's pretty much all you can do in continuity mode. You can't go any further in that diagnostics. Now, this is all done in auto mode, although you can manually just be between those modes yourself by clicking through them. Now I do want to mention when you're in DC, when you're in voltage mode, if you select voltage mode, manual mode, right? So it's not clicking through all the different modes. By default, it's on DC. You click select if you want to do any kind of AC measurements. DC, AC. All right, diode mode. This is where basically most troubleshooting happens. Now, one example of diode mode is like a connector. You want to check all different pins. Now, there is a lot of people also use resistance to do this kind of stuff, but diode mode, I just find it much easier to handle. So diode mode, you use red probe. Now this is a requirement for diode mode. Red probe has to be on ground, so something metal like this, and then black probe is where you touch different pins. So this one gives me 3.331 in diode mode, and you'll actually hear it beeps. Hear that? So this is useful for measuring essentially the resistance on a line. So technically a voltage drop, and based on the value, you can help figure out if there's a problem somewhere. So essentially, these, just off the top of my head, I know these are the backlight lines, and if these backlight filters that are over here, actually, if these filters blow, what will happen is we know there's a we're expecting a reading, like in this one, right? We get a reading of 330 or 328, 0.32829. But if that backlight filter here was blown or damaged or missing, we would get OL, but we get a reading. And the same over here. Now, nice thing about this meter is that it beeps in diode mode, although it's not as sophisticated as the beeping that the Fluke does. Now the Fluke does a long beep when there's a short to ground. Here you can see my diode mode reading is 0000. That means short. On the Fluke, I'll get a solid beep this whole time. On this one, I get a short beep. So basically, anything that's not OL will beep. So see, like right now, these are OL, no beep. Beep, short beep, but this is ground. Another ground. Now a normal reading, 0.578. Same thing. So although it's not as fancy as the Fluke, it does provide that beep, which is super helpful. Although I do wish. So Kaiweets, if you guys are watching this, add a long beep when there's a really low diode mode reading, and this will, I would 100% recommend this meter over the Fluke if it did that. Otherwise, this one's good enough too. If you do want to check for shorts, you would have to basically go back into continuity mode. So you put it in auto mode and then probe. There it goes. It did take a little bit. Some of these pins are ground. Yeah, see, like this one's ground and it beeps. Long beep. Yeah, so in auto mode is measuring resistance right now. Let's see these backlight pins. We have 2.3 ohms, 2.3 k ohms. Yeah, that one is much better because also your board view software like ZXW and JCID, Refox, these have known good diode mode values. So you measure these against known good readings, and then you can help solve a lot of issues. All right, so enough with diode mode. Next is capacitance. All right, so this is if you want to measure capacitor. I do have some already removed off the board. One thing to keep in mind about capacitors is they're often connected in parallel. Basically means it's sharing a connection with other components. So if you measure across it, you're not truly measuring that specific component. You're sharing a connection with other stuff, and it's going to throw off your reading. So you do have to remove it off the board, or at least disconnect one leg from it so it's not influenced by the other components. So to do that is you basically measure across it like this. Although one thing I did notice is that this does take forever to pull up a reading. You saw that it took like I don't know, for like 10 seconds. So when you first probe it, it might read 0 for a while. Look at that, now it says 0.2. Make sure you apply some good pressure as well. There you go, 8.2. Looks like microfarad. I do have another capacitor here. So the risk to this is that if you apply too much pressure, the capacitor will go flying off your probes. So hold it, and yeah, 8.2 microfarad. And I'm saying microfarad because here at the bottom, there's the little icons. N means nano, the little U with the little line. Here, let me see. Now, there is a hold function. Let's see if I could. The trick about hold function is you got to measure it. You got to press the hold button while you're getting the reading. Did I get it? I'm trying to do it one-handed. Oh, crap. Yeah, you need a third hand to do this. All right, let's forget about that. So yeah, that's the capacitance. I mean, I literally never have to measure capacitor, so I don't use that. Millivolts. So this is if you want to measure voltage at a really small level. For micro soldering, it's pretty much never have to measure millivolts. It's usually volts, like most cases 1 volt or more, or maybe 0.9 or something. So that would be 900 millivolts, but that's pretty rare. So let's skip that. Hertz, this is for frequency. I also never use this for phone repair. Here's the temperature setting. So we do have to remove our multimeter probes and plug in the temperature probe. So temperature, actually the lights would have flashed here. So that's one of the cool things about this meter. All right, so hold it, put it back into auto mode, and then click through. And we'll go to temperature, and then you see these lights are flashing. So that tells you use these ports. So red and black. Now we have a temperature reading. So right now it is in Celsius. Now I believe this is room temperature. I'm not too sure. I gotta check the manual. But the big number is what we want to look at. So it's in Celsius. Let's see, and how do we switch it to? I'm not sure how to switch it to. All right, let me turn off. Or I guess it's showing both at the same time then. So if I hold it with my finger, you'll see the temperature goes up. First time using the temperature function on this, so I'm figuring it out here on camera. All right, so let's test this out. Let's see, can we measure the actual soldering iron temp? Let's do this. All right, so this is my action. Soldering iron is set to 380 Celsius. I don't know what temps this thing can handle. So my soldering iron station says 380. Oh, look at that, it's gonna reach. Will it reach 380 or just not making enough contact? Yeah, it's probably not the best for this function then. All right, let's try something else. Let's try my board heater. So I turn this on. All right, set to, here, I'll just show the display. I'm gonna put the temperature probe, for example. I'll press down like that. without burning my hand. So the heater is at 106 and the multimeter says pretty much the same temperature. It's only off. It seems like it's just the timing is off. But yeah, I mean, it detects temperature and it's working. All right, and now the real test is, let's test this hot air station. See if it's, if the probe picks up the right temperature or if the hot air station is uncalibrated. Although I'll probably melt the end of it. So hot air station is set at 350 Celsius. Let's see what happens. I'm like directly on the tip of the probe. Now I don't know if my hot air station is calibrated, so who knows how accurate this is. Yeah, you can see it's taking forever to even get close to 350, if it even reaches that temp. Although I don't know the temperature range of this temperature sensor, but you get the idea. I wouldn't be surprised if my hot air station is not calibrated either. So there you go, temperature. Now we're gonna do non-contact voltage. This is where you can check to see if there's any live voltage at an outlet. This is whether or not it's hot or not. So if you want to check if an outlet is broken, or if, let's say, you flip the breaker switch on your electrical panel and you just want to make sure there's no live voltage there, this is the way to do it. You know, you don't want to be touching wires and stuff if you're not 100% positive that there's no power there. So huge thing for safety. Now while we're here, let's go back to auto mode and let's actually measure for AC voltage, which we didn't do earlier. Just real quick, this I do recommend, you know, you do this if you know exactly what you're doing. We're measuring AC voltage. Do not just stick random things into an outlet because you will get hurt. And look at that. It is in auto mode and actually detected on measuring AC. So it switched to AC and we're getting 121 volts and 60 hertz as well. So here in the US, this is our standard for AC power, you know, outlets. In other countries like Europe, it's 220 or 240, whatever, and I think it's 50 hertz. So there's something to keep in mind. So if you ever want to measure an outlet, this is how you do it. But yeah, be careful. And then lastly, there's the function I didn't cover and I'm not going to cover is milliamps and amps. This is for measuring current through your multimeter. So one thing about multimeters and measuring current is you cannot just probe like I just did for current. You have to put it in line in the circuit to see, basically you have to let the current flow through the multimeter to measure the current. So for example, if you have a light bulb and you want to measure how much current, you know, how many amps is that light bulb using. So essentially what you can do is get one of these probes, put it into positive in your, you know, power supply or power source, then put this probe, so this red probe goes through the meter and out is live voltage here, and then you plug that into the light bulb itself, and then the other, you know, you come back and complete the circuit. And also when you're doing that, you want to be in either you know, whatever amps you expect to draw. So you don't want to go above 10 amps here, and this one you don't want to go above 600 milliamps. So depending on, you know, if it's higher current or lower current, you would swap the probes for that. So you'll see I'll switch to amps and you'll see the lights here will flash. So if you do go over the current limits, you will blow the fuse that is internal to the unit and you'll have to replace it. So I'm not going to show you an example, but just for reference, this is why having USB meters or like a DT880 is awesome, because it has a built-in current consumption and measuring and whatnot. So that's all the main functions. There are some other buttons here, like if you want to, freeze the reading, you push this. Range is you want to adjust where the decimal point is. Min and max, I guess, so you could measure what was the minimum and maximum. All right, and now we have basically this you can use with your multimeter or your DC power supply. They all use kind of the same plug. And so let's take a look inside. Now it does say 23 and 1, although I do think that's a little misleading. I think it means 23 plugs themselves, although a lot of them are duplicated. There is this little booklet here. I'm not too sure what it says. I think it's yeah, you don't need that. All right, so let's go over all the different cables in here. Let's take a look. So these are all dumb cables, right? It's just a cable and plugs for different use cases. So this one is, you can plug it into your multimeter. So take this off. It's really hard. All right, so let's play with it. All right, so just like the last one. So instead of having 2 individual plugs, now we have this. All right, so this actually could have been useful when measuring the capacitor. So I'm gonna switch to, I missed it. There you go. Now I do wish the cable was longer. I don't know how long this is, but it's very short. So instead of having 2 separate probes, we could just try to grab it like that. There you go. So this is one way to measure components. So whatever use case you can figure out where you can use kind of tweezer style probes. So, one side is positive, one side is negative, or, the common and the positive or whatever. So let's see what else is in there. This is kind of like an extension cable set. Well, no, it's actually kind of like modifiable multimeter probes. So this is for your multimeter itself, but this side is actually, let me get these out. You can plug it into one of these. Well, you can plug it into these. So essentially these are, I don't know what you call them, but it's kind of like a needle style, but when you press it, these little hands come out. So this is good for when you're doing larger stuff. I don't ever see myself ever using this for phone repair because this is way too big for anything, unless I have some really large cable or something. I don't know. So there's a set for these. There's a different, essentially multimeter probes. So let me get those out. All right, so here's the complete set. You can do, these are essentially normal size multimeter probes. So this is just like the one that came in with the multimeter. They're literally the same size, although the ones that came with the multimeter are one piece, whereas this one are kind of modular. So, and you can, looks like you could take these caps off as well. Oh, yeah, you gotta pop it off. So weird plug. So these are like standard size, and then they get smaller and smaller. Here's another ones. They do come with like little rubber caps so you don't poke yourself. So on the left is the multimeter probes, and on the right is the one in the cable kit. This one definitely looks sharper, and it gets sharper and sharper. So actually these are like the multimeter kit. These are ultra fine. See, these would be good for diode mode of the board. There's also some other ones that are also ultra fine. They're about the same, just slightly different lengths. These are kind of flexible, so that's kind of weird. And these are kind of like, these are kind of weird because there's like open. I don't know if the heat shrink was not completed or if that's just the design. They're real flexible. Yeah, and they're just basically kind of build your own multimeter. Now you can also plug them in here. So if you want to do like an alligator clip, so you want to clamp onto something, this is not useful for phone repair. This is way too big. These might be, they're slightly smaller. One thing I do want to show you real quick is an example of using these super fine point multimeter probes from the cable kit on an actual board. And actually this iPad board is a lot larger than an iPhone, but let's take a look. So my red probe is going to be on ground like the screw post, and my black probe I'm going to measure. So you can see, actually this one's real flexible. So it's a little hard actually to control. It's a little too fine if you ask me. But yeah, I'm getting readings. It's like even hard to aim because of how tiny it is. Now let me swap these out for these other ones that are also fine point, but they're actually larger tips. Well, the handles are actually larger. So red probe on ground. Actually, this one seems a little more manageable. I think just the handle is a lot more rigid, so it's easier to control. So yeah, I would definitely go with these. If you're gonna use the fine tip probes from the cable kit, these right here. So they're hard plastic here, although the probes are, yeah, these are solid too. The other ones that are on the kit, they're way too wobbly and too soft. These are solid right here. And then lastly, another thing you can do is, like I mentioned, if you cut these sleeves off, so you can plug this into your DC power supply, and you can use these to inject voltage into a board when there's a short. I don't know if you want to do super fine tip like these, or maybe go with the little larger tips like these, but you know, you can use this as well. And also you can mix and match. You don't have to use the exact same ones. So for example, previously I was using for my DC power supply, whenever I want to connect an iPad board, I would actually do this. So let's say for example, this board, I would have, you know, this end connected to my DC power supply. I would actually use just the red from here, so I could clamp onto the positive connector on the battery. And I use this one to clamp onto anything metal. So like a screw post, black for ground with the clamp, with the alligator clamp. So I can easily just grab any shields or whatever. And then this one for the positive battery terminal. You know, the goal is really to have a positive and negative connected so that you can power the board, and that's what I'm doing. So, you know, mix and match, make it work for your use case for what you're doing at that moment, and it'll work out great. All right, so let's go over the main pros and cons. I would say the main pros is the price. And I'm talking about both products here. It's all the same brand. You know, the price is good. There's a lot of functions and features built in. The screen is pretty nice on this thing. You know, having the auto function is helpful, although I don't know, I still gotta play with it, see if I'm ever gonna use it often. I do like on my Fluke, I'm basically just always in diode mode. I would say 90% diode mode, 10% voltage mode. It'd be awesome if this had diode mode and voltage mode auto detection. That way I don't have to spend the extra 2 seconds to switch between modes. Another pro is it does have beeps, although I would say this is like half a point, that it does have beeps, but it doesn't have the variation of beeps like the Fluke. But you know, you are paying a fraction of the price. I do wish, so the con is I do wish it had a stand or at least some mounting mechanism so I could like zip tie it. Because my Fluke, I actually have it mounted right above my microscope, so when I'm working on something I could quickly just look up without moving my head too far. and this has nothing, lanyard hole or anything, and it is the shape of a phone, so you would think they would, I don't know, I guess they were trying to stick with the phone shape, and having a kickstand or anything would have maybe thrown that off, who knows. But yeah, I mean, I think it's nice. Now I don't know if the battery life is any good. I think I swap out my Fluke battery like every 6 months to 9 months. It's a very long time, and I never turn it off. I just always let it just fall asleep and use the auto power off mode. So this has auto power off as well. So it'd be interesting to do a side by side, although that's way too much work. I'm not gonna use this for 6 months straight just to see how long the battery lasts. But you know, the AAA batteries, you know, these are cheap. You could buy a 20, 50 pack on Amazon for pretty cheap. So yeah, let's see what else. I mean, there's not much else to it. I mean, it's a multimeter. You can't really go wrong. In most cases, especially for what we do, we don't need super high accuracy. As long as you notice something is off, usually it's off. You can tell there's a difference. So I don't know. What do you guys think? Let me know down below in the comments. Do you guys enjoy this video? If you did, smash that like button, subscribe to the channel, check out the links down below if you want to buy one of these, the cable kits, or any other tools that I recommend and link to. It's all down below. Get yourself a t-shirt if you want to support the channel. Join the locals community, which I will also link down below, where you can post questions. I post there regularly, you know, different repairs that I come across, kind of how I solve them and the stories behind it, with pictures and everything. So hope I see you there in my locals community. And that's pretty much it for me today. I'll see you guys in the next one.